Right, and question 2 now says, Akil was given a large rectangular block of plasticine and asked to find its density. Describe how we could do this using only a beam balance and a half-meter rule. So let us start to talk a little bit about density. What is density? So can you use any point on the graph? Yes, you can use any point, but you want to use 2 points that are far apart. If you notice, when I found my gradient, when I was finding my gradient, I choose 2 points that are far apart. The further they are, the better the value for the gradient will be. So where are we now? Right. So we want to talk about density now. So what is density? Anybody know what is density? Mass over volume, right? So that's the formula for density. But the definition, let's write a definition for density. Density, we say that this is the mass per unit volume of a substance. So therefore, we can calculate density by saying that density rho is equal to mass divided by volume. So now, in this case, they say they want us to explain how we can actually find the density of a rectangular block of plasticine using a beam balance and a meter rule. Do we know what is a beam balance and what it is used for? What do we use a beam balance for? What do we use a beam balance for? Anybody? Yes, no? You have an idea what the beam balance? Measurements, yes, we use it for measurements, but what specifically do we use it to measure? To get the mass, right? We use a beam balance to measure the mass of objects, right? And you notice, for us to find density, we need to know the mass of the object, and we also need to know the volume. So we can use, one we're going to say use triple beam balance. I'm going to say TBB, which means triple beam balance, to measure the mass of the plasticine, right? So we can obtain the mass by using the triple beam balance. Now, the next thing we need to know to find the density is we need to know the volume of the substance. And they say that it's a rectangular block of plasticine. So we can imagine that this is our plasticine here. We can imagine this to be our plasticine like this, this, right? So this is our plasticine. So we can measure its mass by placing it on a triple beam balance and obtaining the mass. How could we find the volume of this rectangular block of plasticine? How would we be able to find out the volume? Remember, we only have a triple beam balance and we have a meter rule. So how could we find the volume? Any ideas? Please don't be afraid to say what's on your mind. I want us to be able to engage so we can hear from each other and also work through these questions together. So again, how could we find the volume of this rectangular block of plasticine? And we have a triple beam balance and we have a meter rule. What could we do? What could we do? Measure it? Yes, we could measure it. How? But how? How would we measure it? How could we measure it? First of all, what would we use to measure it? What would we use? All right, first of all, before we start to think anymore on this, let us say we have this rectangular block. How could we find the volume of this rectangular block? What do we need to know? Or how do you normally, back in your math class, when you were doing math, how would you normally find the volume of a rectangular block like this? How would you find the volume? Is there a formula we can use to find the volume of a rectangular block? Yes, what's that formula? And what's the formula for the volume of a rectangular block? Huh? Right, length by width by height. So volume is length by width by height. So we need now to actually be able to figure out the length, the width, and the height of this rectangular block. Right, and again, we have a beam balance and a half-meter rule. Anybody know what we use a half-meter rule for? What is a half-meter rule used for? What can we measure with a half-meter rule? What physical quantity? What physical quantity we can measure with a half-meter rule? Sabrina, what physical quantity we can measure with a half-meter rule? Can someone type length in the chat? Oh, okay, okay. Okay, so can someone type length in the chat when I ask the question? What physical quantity do we use a half-meter rule to measure? I want somebody to type length. Length, that is correct. So we use a half-meter rule to measure length, right? So therefore, we can take our half-meter rule and measure the length, the width, and the height of this object, right? So we can use our half-meter rule to measure the length, the width, and the height. So we're going to say, step 2, use half-meter rule, to measure length, width, and height of this rectangular block. Then now we're going to say 3, use V equal this formula right here, length by width by height to find volume. And then finally, in part 4, we say use formula rho equal m over v to find density. That makes sense? That makes sense? Okay, cool. All right. So we're gonna start imagine that we actually did this. So I'm just going to give you some values and then we are going to look at it together. So let us say after placing this on the triple beam balance, we get a mass M of 40 grams, right? We get a mass of 40 grams, right? 40 grams. Or as a matter of fact, let's make it SI units. So let us say maybe 20 kilogram, for example, right? So 20 kilograms. Now let us say now when we measure the length. So let us say I'm going to just put down the values here. So the length is given here, the width and the height. I'm going to give you these values, right? And let us say this is maybe 2.5 meters for argument's sake. Width is 1.0 meter and height is 2 meters. All right, let us say these were the dimensions that we obtained when we use the half-meter rule. So what I want us to do first is to calculate the volume. So I want you to calculate the volume for me, please, and post it in the chat. Or shout it out if you are willing to shout it out. Has anyone calculated the volume as yet? Carolina, Sabrina, Daniel, have you calculated the volume? Okay, 5 meter cube. Okay, cool. So we say volume is length by width by height. So we get length is 2.5 meter. Width is 1.0 meter, and the height is 2 meters. When we multiply these out, we in fact get 5 meter cube. Is everyone okay with that? Everyone got the same answer there for the volume? Okay, cool. So then now we know the volume, we know our mass. So we can now simply apply our formula. Rho is equal to mass over volume to calculate our density. So can you calculate the density for me, please? Yeah, so what would the volume be in this case? Okay, 4 kilogram per meter cube, correct? So our mass is 20 kilogram and our volume is 5 meter cube. So in this example here, we get 4 kilogram per meter cube. Very good. Any questions? Okay, cool. So now, by the way, how are you guys feeling? Are you guys okay to continue? Okay, cool. All right, so let's continue with this then. So we will move forward, and here now it says to use the graph on page 7. Well, let me read it properly. So it says the graph on page 7 was plotted using Akil's results obtained from several blocks of plasticine. Use the graph to complete table 2 to show the mass of 5 different blocks of plasticine and their corresponding volumes. So for this, what we'll have to do is to use our graph. All right, this is our graph right here, and we're going to choose any, how many points did they say? Any 5 points on our graph. So we're going to choose any 5 random points and read off their values. So I'm going to choose the points, and then we're going to go through and read off the values. All right, so let us say I choose a point here. I choose one maybe here. Choose one here. One here. And finally, I choose one maybe somewhere about, maybe here. All right, just to be a little different. So these are our 5 points that we chose. So now we need to actually read off these coordinates. All right, so we're going to read off from the y-axis and also from the x-axis. So this point right here, what would be the values for this point in terms of the y value and also the x value? What would it be? Let me put a bracket here. First, let's read the x first. What would this correspond to on the x-axis? This is 2 right here, and then we have 4. So we have 2. This is 4. So this is 2.4, 2.8. All right, 2.2. Well, close. It's actually 2.4 because each of this. Let me just double check. This is 2, and this is 5. So if we say 2 divided by 5, 2 divided by 5. Right, it's 0.4, right? So each of this is 0.4. So we'll have 2, 2.4, 2.8, 3.2, 3.6, and 4. So this here would be 2.4. So we'll get 2.4 for the x, and for the y, we will get 5 for the x. Is that clear? Okay. Then for this one, we'll do the same thing, right? What do you think this one would be in terms of the x? What would it be? What point does it correspond to on the x-axis? This point right here. 8.4, yes. So 8.4, 8.4. And on the y, what would it be on the y? 15, very good. So 15, and then we close there, and then we can continue with this one. What will this one be now? On the x? What would this point be for the x? 14, yes. And then for the y, what would it be on the y? 25, yes. And then we will continue with this. Let me just go here. All right, for this point now, what would it be on the x? 18, yes. And similarly, on the y, what would it be? This is 30. This is 35. So what would a halfway between 30 and 35 be? What is halfway between 30 and 35? Huh? What would halfway between 30 and 35 be? Huh? All right, let's look at it this way. This is 30 and this is 35. So the space here is actually 5 because 35 minus 30 is 5. So here occupies 5. So what is half of 5? What is half of 5? 2.5, right? So this is 30 and this is 35. Halfway between here is 32.5. Make sense? Does that make sense? Okay, cool. So now we'll have 32.5. And then finally, let's look at this one here. So that one is up there. This one is kind of tricky because I can't really see the entire paper. All right. Tell you what, let me just choose a different point. So to make my life a little easier. So I'm going to choose this point here and do the same thing. So here I can actually see the entire graph or see the point and see the x-axis. Oh, it's almost not even another thing. It's still a bit strange. Anyways, maybe I can zoom. Maybe I can zoom out. Maybe I can zoom out like this. Yes. So this is the point, right? On the x-axis, what would the value? What value does this point correspond to on the x-axis? If we go down here, what point does it correspond to on the x-axis? 2.25.4. All right, so it's actually 26 on the first point. So it's 26.4. All right, 26.4. All right, so it's 26.4. All right, on the x, and then for the y, let me zoom back in for that one. So let me zoom in back. Where is it? All right. So now for the y, what would it be on the y-axis? Right, again, we have 40 right here, and this is 50. So what would halfway between 45 and 50 be? Check again, 40 and 50. 45 and 50. 45 and 50. So try again, Daniel. Remember, 45 and 50. So what would halfway between 45 and 50 be? Sabrina, can you help out? What is a close, a close. One more try, Daniel. That was a little closer. Remember, what you want to do is you want to add half of 5 to 45. And half of 5, as you know, is 2.5. So you want to add 2.5 to 45. So what would it be? 47.5, correct? So it will be 47 0.5, and then we would simply just put these values in our table. All right, so we'll put these values in our table here. All right, now I'm going to move on to the slope. So we're going to find the slope, right? So we're going to say m, which is our slope, is equal to y2 minus y1 divided by x2 minus x1. So again, we simply choose some points, right, far apart. So I'm going to choose a point here, and I'm going to choose another point here. I'm going to do this a little quickly, so hopefully, as I go through it quickly, you're able to follow along. But if not, stop me, and I will ensure that I go over it again. All right. So quickly, for y2, we'll simply read off y2 on our y-axis. That is 45. So we can write it in that y2 is 45. On the y-axis, we had grams. So we're going to say 45 grams minus y1. In this case, y1 is here. So what is y1? What would y1 be? Oh, sorry, it's right here. This is the point. So what is y1? 5? Well, no. It's a green point, not the red point. So let us look at it. So this is 5 and this is 0, right? And we have 10 lines between them. So therefore, each of these lines is 0.5. So we have 0.5, 1, 1.5, 2, 2.5, 3, 3.5. So this is 3.5. Is that clear? That's clear for you, Sabrina, Danielle, Karagina. It's clear? Okay. Because as I said, we have 0, this is 5, and we have 10 tiny blocks in between it. So we simply divide 5 by 10 to find the value of each tiny block. So each tiny block is 0.5. So we have 0.5, 1, 1.5, 2, 2.5, 3, 3.5. So this is 3.5. So we can write it in. Where was it? All right. So 3.5 grams divided by x2 minus x1. So we chose this point. So we have to read off x2 and x1. So let me do that quickly. So, all right. So this is the point. So it comes all the way down here. All right. So this is 24.4, 24.8, and this is 25.2. Right, so this is 24, 24.4, 24.8, and 25.2. Right, if you guys didn't catch that, let me know. 25.2, and this is centimeter cube. All right, did you guys catch that a while ago? Because we are at 24 here, and each of this is 0.4. So 24 here, 24.4, 24.8, plus another 4 will give you 25.2. So we get 25.2 for this point. Is that clear? Is that clear? Is that clear? It's not clear. Okay, cool. All right. So let me go over it once more. So, all right. So if we look at our x-axis, this is 24 and this is 26. So the difference between 24 and 26 is 2. Right? The difference between 24 and 26 is 2. Now we have 5 tiny blocks between 24 and 26. So what we'll say is 2 divided by 5. What is 2 divided by 5? As a decimal, what is 2 divided? 0.4. 0.4. So therefore, it means then that each of these small blocks is 0.4. So if, let's go back up to our point. If this is 24, this would be 24 plus 0.4, which will give you 24.4, plus 0.4 again, 24.8, plus 0.4 again, right? So we'll have 24.8 plus 0.4. What will that be? What will that be equal to? what was this? 25.2, and that is how we got 25.2. Is that clear now? Right? Okay, cool. So we can simply write it in then as 25.2, already did that, and then we'll do the same thing here. So now we have 2 right here, and it is located at the second tiny block of the 2. So can you tell me what will this one be now in terms, oh, sorry, it's actually this one. So real life is easy. So it's actually on the line. So what would this point correspond to on the x-axis? What would it correspond to? 2, right? Very good. So we'll just simply write it then as 2 centimeter cube. Right? Now, somebody calculate this for me, please. First, calculate 45 minus 3.5 and tell me what you get. And let's just fill that in and then go through. So what would this be? 41.5, right? So 41.5 grams. And what would this be equal to? 23.2, right? 23.2 centimeter cube. So what I'll ask you to do now is to simply finger this, divide this out and tell me what you get. So our gradient M will be equal to whatever this is. So can somebody work this out for me, please? Has anyone found the answers yet? Has anyone, okay, 1.79 gram per centimeter cube, very good. So we get 1.79 gram per centimeter cube, right? And this here, this value here, actually, what do you think this value here represents? What do you think this value represents? What do you think this value, 1.79 gram per centimeter cube, represents? Huh? What do you think the value 1.79 gram per centimeter cube represents? Any ideas? Yes, no? Place a Y for yes, N for no if you're not sure. Do you have any idea what the value 1.79 gram per centimeter cube represents? No? Okay. How about you, Daniel? Any idea? Any idea? No? Okay, cool. So, okay, so let's look at something up here. Here, I wrote that the density is the mass per unit volume of a substance, and we can calculate it using the formula. Where density is equal to mass divided by volume. Now, if we look at our graph, right, we add mass on the y-axis, and we add volume on the x-axis, right? And since our gradient is y2 minus y1 divided by x2 minus x1, right, okay, density, right? So effectively what we did was to find the gradient, we divided what was on the y-axis by what's on the x-axis. So in fact, what we did was to divide mass by volume, right? And we got 1.79 gram per centimeter cube. And also, based on the unit, gram, we use gram to measure mass and centimeter cube to measure volume. So we divided mass by volume and get our answer right here. Is that clear now, Sabrina? Okay, perfect. All right, so that's that for that. And then let us see what else they want us to do. So we did that. Okay. Okay, so it says use, or one more thing, they said use the value of the slope you calculated in that to find the relative density of plasticine. So once you're talking about relative density, right? So we say PREL, which stands for relative density, is equal to the density of a substance divided by the density of water, right? So the relative density is the density of the substance divided by the density of water. Now in this case here, they give us the density of water as 1 gram per centimeter cube. So we'll write that the relative density of plasticine in this case is equal to the density of plasticine, because that is our substance, divided by the density of water, right? So we're going to scroll back up now to look at our value for the density of plasticine. What is it, the value for the density of plasticine here? What is it? 1.79, right? 1.79 gram per cm cube. So we write 1.79 gram per centimeter cube divided by the density of water, which is 1 gram per centimeter cube. So we say 1 gram per centimeter cube. Now, let me ask you, what would the value be for the relative density of plasticine? I need its value, and I need for you to tell me whether or not it has a unit, and if it does, what is the unit? So what would be the value for the relative density of plasticine when you divide 1.79 gram per centimeter cube by 1 gram per cm cube? What would it be? Okay, perfect. So it's going to be 1.79, and Sabrina, Daniel is saying with no units. Do you agree, Sabrina, that we should not have a unit here? All right, they cancel out. Do you agree? Okay, perfect. So since we have the same units, they cancel out in our calculation right here. So the final answer will simply be 1.79 without any unit. And in fact, the relative density of a substance is what is referred to as a dimensionless quantity. So therefore, it has no units. All right? Is that good? Okay, perfect. So now, do you want us to talk about this question here? I know we have been going on for quite some time. How are you guys feeling?